Hey guys, Remy here. So Ethereum had just undergone a major upgrade with massive improvements by way of a hard fork known as the London hard fork. So let's talk about it. Firstly, how does an upgrade work? Well, all of the nodes that are running the Ethereum network are running a version of the Ethereum client. All they would have to do would be to upgrade their clients to the latest version, and that's all. All in all, it's a very seamless process and one continue to use the Ethereum network as before. So let's talk about the changes. By far and away the biggest change was the EIP or Ethereum Improvement Proposal 1559, which introduces the base fee per transaction. This base fee is like the base amount that you would have to pay per transaction, and then you would have to pay the gas fee on top of that amount. The base fee itself is predictable as it is bound by the lower and upper bounds, and it is basically a function of the previous block's target per gas. This means that so at the moment the Ethereum the London hard fork is already live, so when I say at the moment I mean before. So before you used to pay the gas fee as a whole amount, and that gas fee was basically the transaction fee that went over to the miners or the validators, as will be in the future. Now each transaction has a base fee and the gas fee is on top of that. So the base fee itself is completely predictable as it is a function of the previous block's target per gas, and the gas fee itself is paid on top of that in order to make your block a priority, fast, slow. It's that hasn't changed. The one thing that's changed is that since half of the gas fee, or however much percentage of the gas fee the base fee actually takes, is now predictable, one can more reasonably predict the actual gas fee, the total amount that you will have to pay in order to process a transaction. This means that you will be able to build programs that will rely on a predictable gas fee in order to function properly. Your wallet, for example, will be able to suggest the gas fee on its own, and you will no longer have to manually import it in order for your transaction not to be rejected. It will also result in far fewer transactions actually being rejected. Now, the gas fee, as before, will go to the miners or the validators as the transaction fee per transaction inside of the block, but the base fee, now this is interesting, the base fee will actually be burnt. So this is huge for Ethereum, and I'm going to come back to it because I'm going to relate it to another point I'm going to make in a bit. Another change is that the blocks are now dynamically sized, meaning that if there is a massive congestion in the network, then the blocks will expand in order to facilitate more transactions within a block. Whereas when the network is not as congested, the blocks will basically be smaller, meaning that they'll be processed faster by the miners. Now, what is the reasoning behind this, and why can't we just keep uniform size blocks going forward? Well, inefficiency. Basically, based on how the gas fees work, the last transaction that can be fit into a block is way more expensive than the second last transaction. And the second last transaction is likewise way more expensive than the transaction before it, and so on, which means that most users that perform those transactions don't actually grab that last spot in a block in order to be processed because it's way too expensive. They tend to wait for the next block and fill the lower spots in order to pay less gas. This leads to inefficiency in two ways. One, the block will be mined before it's actually filled to capacity, meaning that nobody's grabbed that last spot, and the block will be mined, that a block that is not completely full will be mined, and the transactions that are waiting for the next block will basically be waiting for the next block or the block after that in order to be processed. So this leads to inefficiency in that very way, meaning that the blocks that are not actually full are being mined, whereas the users are waiting for the next block in order to pay less gas. So dynamically sized blocks actually solve this issue because they reduce the overall gas fee you'd have to pay to be the last, because the block will just increase in size and there will always be a guy after you within reason, because it's bound by it's within the range bound by an upper bound, meaning that the block cannot grow way out of proportion so that no miners will be able to process it. But still, it is a great solution to this problem. Now, let's go back to the burning of the base fee, and let's really talk about it in depth. Now, so why would we burn the base fee? There's a few reasons for it. So Ethereum has no limit of how much Ether can exist in the circulation, unlike some other networks like Bitcoin, as you well know, has a has a cap on its circulating supply that that is 21 million. So let's talk about that. That means once all of the 21 million coins of Bitcoin are mined, the only reward for the miners will be the transaction fees of the transactions that are included inside of a block. At the moment, on top of the transaction fees that are included inside of the block, the miners also get the block reward, meaning the new Bitcoins are minted per each block, and that's how the supply actually increases. As soon as the supply runs out, as soon as the network actually reaches 21 million coins, the only reward will be the transaction fees, and this leads to a huge problem and a huge security issue for the entire network. One such this problem is called selfish mining. So let's talk about selfish mining. Alright, so consider this. At the moment, let's draw a block. So this is a block inside of a Bitcoin network. I'm just gonna talk about Bitcoin in this example because Bitcoin is the one that has a limited supply of coins and Ethereum does not. So each of the transactions inside of a block that is mined by a miner, let's just say transaction 1, transaction 2, and so on. Each of these transactions has a transaction fee associated with it. So for example, let's say like it's obviously not going to be 2 Bitcoin, but say 2 Bitcoin, 2 Bitcoin, and so on and so forth. So all of these transaction fees add up to the entire reward that is given to the miner that actually mines this block. Now, on top of the transaction fees, at the moment, Bitcoin rewards the miner of the block with a newly minted Bitcoin called the block reward, and at the moment it's something like 6.5, I believe, or was it 6.25? Anyway, so this is the block reward of the Bitcoin. This is new Bitcoin that is minted and added into the supply, and it's halved every 4 years, approximately, give or take. So as soon as all of the 21 million Bitcoins are mined, the blocks will only have transaction fees that are going to be made as a reward to the miners. So the only incentive the miners will have are these transaction fees. So some amount of Bitcoin per transaction, and the more transaction fees the block contains, obviously the more money you have. So there is not going to be any guaranteed block reward. Okay, now why is this a problem? Now mining, as you know, costs electricity, right? So in order for this to be justifiable, in order for mining to actually make sense, the combined sum of all of these transaction fees must be greater than the amount of money that is spent on electricity running your mining rig for the amount of time that you would mine the block on average. So suppose you're the guy who so this is this block, right? And you can see this block on your network because you're a miner and you're just sitting there and you're waiting. Okay, 1 transaction, 2 transaction, 3 transaction. Okay, that's still not enough. So you're just waiting. The 4th transaction is added. Okay, that's still not enough. Okay, 5th transaction is added. Suppose the 5th transaction was enough, and with the 5th transaction you actually tip the amount so that this amount is actually now greater than the electricity you've spent mining this this block. So at this point, once you have enough transactions to justify the cost, you start mining the block. Okay, so you mine the block, you run the risk of somebody else mining this block before you, and if they do, then basically you lose out on all of these transaction fees and you still have to pay the electricity. So you still have to pay for your electricity because it's not free, but you did not get all of this money. Somebody else got this money, and then you try to mine the next block and so on, and you run the same risk of losing this money. So with the block reward as before, you had a guaranteed income, whereas with this one you don't have a guaranteed income. So as soon as somebody else mined this block, you have to wait for the next block, and you can't just start mining the next block immediately because there is no guaranteed income as there was before. The 6.5 Bitcoin is no longer there. So you have to again wait for the transaction fees to justify the cost of electricity. And that means that somebody else might begin actually mining this block before you. Maybe they have cheaper electricity and they need less transaction fees. Basically, it leads to this situation where not only will the transaction fees take way longer to process because the miners will be waiting and waiting and waiting for the transaction fees to actually fill the block before starting to mine, but they'll also run the risk of actually gaining nothing. A better strategy for miners, and this is called selfish mining, would be this. Check it out. So suppose I am the miner, yeah, and I have this block. It has 0 base reward, but it has a bunch of transaction fees, right? So suppose I get lucky and I wait for enough transactions, and all of this justifies my electricity cost, or even if it doesn't, actually it doesn't matter in our case because that's how selfish mining works. So let's just say in the first case it does. So I start mining this block and I mine this block successfully. So this block is mine and I get the rewards. So in a good mining situation, I would publish this block, right, for the rest of the network to see, so that these transactions will actually go through. Now, here's what I do. I don't publish this block. I keep this block to myself on my private network, and I immediately start looking for the next block based on the new set of transactions that's coming in. So I didn't publish my first block, and I am already looking for the second block on my own private network. So doesn't matter how many transactions I have here, just get a bunch and then start mining the second block immediately. So you are already mining the second block while the rest of the network are only mining the first block. Since you haven't published it, it still hasn't been officially mined, so they're still on the first block while you are already on the second block. So as soon as they publish that first block, so they have now mined this block and they've published it, you can now so this basically means that you have a head start on mining that second block. So you might find the second block even before they find the first block. But even if you don't, so suppose they find the second block, the first block first, yeah, and they publish it, which is normal, you're still looking for the second block. Now, chances are, and the chances are big because you had such a massive head start, that you on your private network will find the second block before the rest of the network will. And then what do? Well, you publish both of these blocks at once, abandoning the last chain, because the consensus of the Bitcoin network and the Ethereum as well, and any other blockchain basically, is that you always follow the longest chain. So you've just published 2 blocks versus the rest of the network's 1 block, which means that you've basically claimed the rewards for the first block and stolen them from the miner who actually verified that block and published it to the chain before you, because you kept it to yourself. And you've also claimed the rewards for the second block, because you had such a massive head start actually doing this. You found it before the rest of the network, and now you published the 2 blocks. You've effectively orphaned the other chain that was published on the network, and now the network is following your chain, and you've gotten the rewards of both of these. Now, as you can imagine, why stop at 2? Now you found the second block, the rest of the network has only found the first one. Let's keep going. Let's go 3. Why not go 4? Maybe even 5, and so on and so forth. And you keep doing that. You basically are financially incentivized to do this instead of the traditional mining, because you end up making more money this way. This means that all of the miners are going to be doing this, or at least the majority of the miners are going to be keeping their own private chains and try to outrace each other in finding the blocks and not publishing the blocks one by one. Now, the issue here is that basically all of the transactions are going to be processed way slower because nobody's publishing their blocks. And also, if nobody's publishing their blocks and all of the miners are mining for an extended period of time on their private networks, a 51% attack will actually be far more likely to take place, meaning that a malicious miner can actually mine proper block, and this is his private network still. He has the longest chain, right? And he had a head start over the other miners. So he's just gonna keep mining, and he might include fraudulent transactions here. So this is a fraudulent transaction where he may be adding to his own balance a massive amount of Bitcoin that he doesn't actually have. And then he's gonna mine the next block on top of that, legitimate transactions, and he's gonna publish his chain of 4, while the rest of the network is only up to 3, and this chain is going to be accepted by the rest of the network because it is the longest chain, and the rest of the chain is going to be abandoned, and this is actually going to be the fraudulent chain. So this is what happens when you do selfish mining and when you have no block reward. Now Ethereum doesn't have this problem, because in Ethereum there is no cap on the circulating supply, meaning that you will always have that fixed block reward. But if you always have the fixed block reward, that means your supply is always increasing. It's always going up. So what this does is this causes your currency to become inflationary, causing inflation to take place. And inflation is not the goal of the Ethereum community and the Ether in general. So basically, in order to counteract inflation and make the price a little bit more stable, the base fee that it was the gas fee previously, which is the base fee is actually now the percentage of the gas fee, that's actually burned. So even though you mint a whole bunch of new ethers per block, so that block reward is never going away. So you keep on minting the so the miners keep on getting their fixed reward per block, effectively counteracting the selfish miner problem that the Bitcoin network is going to experience as soon as all of the Bitcoins are mined, or even sooner when the reward is not sufficient enough. So the block reward will keep on being there, but you will also burn the base fee, meaning that the supply is not going to grow, but rather be stable, because you mint new coins, but you also burn coins. I mean, the supply is going to be more or less stable. Now, if there is more coins minted than the supply burnt, that means it's going to be inflationary. If there is more supply burnt than the coins minted, it's going to be deflationary, meaning that the price of Ether is going to increase due to the dwindling supply. However, there is no specific mechanism in order to, due to the volatility of the congestion of the network, you can't exactly predict whether there's going to be more coins minted or where there's going to be more coins burned due to the base fee burning. So there is no way to say if it's going to be inflationary or if it's going to be deflationary at the moment, or not at the moment. Again, I said that. So before the London upgrade, it was completely inflationary because you were just minting new coins, but none of them were being burnt. Now it's going to be more stable. So even if there's more coins minted than burnt, it's still not going to be as inflationary. It's going to be like more of a straight line. And overall, what it's going to do is it's going to stabilize the price a lot, meaning that it's not going to be, it's going to be a lot less deflationary than, say, Bitcoin, but a lot less inflationary than it was privy to this upgrade. So this is this wraps up the first major improvement of Ethereum, that is the Ethereum Improvement Proposal 1559. Now let's talk about the next one. So there are a few more rather minor upgrades to the Ethereum network with the London upgrade, and one quite big one. So let's talk about them. So the next one is basically there's one that basically makes the base fee available to the EVM, and that pretty much means that smart contracts can access the block's base fee. And what this allows the smart contracts to do is basically build programs that can take that base fee into account and calculate it in certain ways, and just basically build programs that rely on knowing what the base fee was and how much Ether was burnt in that transaction, in that block. So then there's it's going to be reduction of refunds, it's going to be rejection of the contract, such as the all times execution function, I think that it means. But the next big upgrade was this one, the difficulty bomb. So what does the difficulty bomb actually do? Well, the difficulty bomb is something that was introduced onto the Ethereum network with this upgrade, and what it's gonna do is basically it's gonna constantly over time gradually make mining more difficult, meaning that it's going to gradually, block by block, make the hash function of the make the actual hash algorithm of the function that the miners have to hash in order to actually validate the blocks. It's gonna be gradually made more and more difficult, block by block, all the way through to December 2021. And this is called the Ice Age upgrade, or a difficulty bomb, meaning that eventually it's gonna make mining completely unfeasible and it's gonna go straight through onto the merge with the proof of stake. So because they made it the made date of the actual freeze December 2021, that means that this is the probable date for when the actual proof of stake network is gonna go live on the mainnet, and all of the Ethereum network is gonna be merged with the proof of stake network beacon chain. And to incentivize miners to switch over to the proof of stake network and basically give them a massive disincentive to continue mining the proof of work network, that's what the difficulty bomb is there for, in order to basically make it way more difficult block by block until it's completely unfeasible, so that people are incentivized to switch to the new proof of stake network. So this wraps it up for the London upgrade. I hope you found this video informative. My goal was to talk about the changes in depth, analyze the motivations behind them, and talk about what the changes actually meant for the network in technological detail. Hope you enjoyed this video, and as always, I'll see you in the next one.